Did you know light-emitting diodes, or LEDs, are taking over? Once confined to electronics, they now illuminate our homes and cities. LEDs are tiny semiconductor devices. They release photons of light when electricity flows through. Unlike incandescent bulbs, LEDs don't rely on heat to produce light. This makes them incredibly efficient and long-lasting. Before we embark on our journey to create an LED lamp, we must assemble our tools and components. Fear not, for this is no Herculean task. You will need LEDs. These are the stars of our show, available in a variety of colors and sizes. Choose your preferred hue and luminosity. Resistor. This humble component ensures the LEDs don't burn out from excessive current. We'll discuss selecting the right resistor later. Wires. These act as the conduits, carrying electrical current to our LEDs. Battery holder. A secure home for our power source, typically AA or AAA batteries. Switch. This optional component grants us control over the flow of electricity, allowing us to turn our LED lamp on and off at will. Soldering iron and solder. These tools help us create permanent connections between our components, ensuring a robust and reliable circuit. With our components assembled, we can now begin constructing our LED circuit. This is where the magic truly happens. Don't worry, the process is straightforward, even for those new to the world of electronics. 1. Prepare your wires. Cut 3 pieces of wire to a manageable length, about 10 centimeters each. Strip a small portion of insulation from both ends of each wire, exposing the bare wire beneath to connect the resistor. Take one wire and carefully wrap one of its exposed ends around one leg of the resistor. Secure the connection using your soldering iron and solder. 3. Connect the LED. Take a second wire and connect one end to the other leg of the resistor, again securing the connection with solder. Connect the other end of this wire to the longer leg, the positive side of the LED. 4. Connect the battery holder. Connect the remaining wire to the shorter leg, the negative side of the LED. Connect the other end of this wire to the negative terminal of the battery holder. 5. Complete the circuit. Connect the positive terminal of the battery holder to the remaining free end of the wire connected to the resistor. It's crucial to note that LEDs, unlike incandescent bulbs, have polarity. This means they have a positive and a negative side, and electricity must flow through them in the correct direction. The longer leg of an LED is typically the positive side, while the shorter leg is the negative side. If you connect the LED backward, it won't light up. Section 5, resistor, the unsung hero of circuit stability. You might be wondering, why do we need a resistor? Well, the answer lies in the delicate nature of LEDs. These tiny light sources are highly sensitive to current. Too much current can overwhelm and damage them. The resistor acts as a gatekeeper, limiting the flow of current to a safe level for the LED. Choosing the correct resistor value depends on the specific LED and the voltage of your battery. With our circuit complete and the batteries inserted into the holder, the moment of truth has arrived. Flip the switch if you've included one, or simply ensure the circuit is closed. If everything is connected correctly, your LED should burst forth with light. Congratulations, you've harnessed the power of semiconductors to create your very own illumination device. Don't be disheartened if your LED doesn't light up on the first try. Electronics can be finicky, but with a little patience and deduction, you can usually identify and resolve the issue. Here are some common troubleshooting tips. Check your connections. Ensure all wires are securely connected and soldered and that there are no loose strands touching each other. Verify LED polarity. Double check that the LED is connected with the correct polarity, positive to positive and negative to negative. Test your battery. Make sure your batteries are fresh and inserted correctly in the holder. Inspect the resistor. Ensure the resistor is the correct value for your LED and battery voltage. With your LED glowing brightly, you've successfully navigated the fascinating world of electronics and emerged victorious. Now you can personalize your creation. Encase it in a housing of your choosing, add a diffuser to soften the light, or connect multiple LEDs together to create a string of lights. The possibilities are limited only by your imagination. As you enjoy the brilliance of your handmade LED lamp, it's worth reflecting on the broader impact of this revolutionary technology. LEDs are significantly more energy efficient than traditional incandescent bulbs, using up to 80% less energy for the same light output. They also last significantly longer, with an average lifespan of up to 50,000 hours, compared to just 1,000 hours for incandescent bulbs. This translates into significant cost savings and a reduced environmental footprint. By embracing LED lighting, we're not just brightening our homes and cities, we're illuminating a more sustainable future.